section 3.3, the slope of a line. So we're going to talk today about slope of a line. I know that there's probably a lot of phrases or formulas that come to mind when you think of slope. We're going to kind of assume that there's no background knowledge here, and we'll build it up from there. So let's see what we have to look at today. All right, so the point of slope is that we can use it to measure the steepness of a line. A common mistake we mentioned in class the other day is that we sometimes think about just vertical or horizontal lines being straight, when in reality, all lines are straight. But they are different because some are steeper than others. Lines with large slopes, whether positive or negative, are very steep. They're really steep going up or coming down. If you put a ball on it, it would roll right down. Lines with very small slopes are either positive or negative or fairly flat. They're just a little bit of an incline, just a little bit of a decline. Ball would roll, but just not super fast at first. Then we have the other two special types of lines. The vertical lines, right, up and down, have an undefined slope, and we'll talk a little bit more about why that is afterwards. Horizontal lines have a slope of 0. Horizontal lines like this have 0 slope. They're completely flat, so a ball wouldn't roll on it at all, whereas a vertical line, there'd be nowhere to put the ball. It would just drop straight. We try to avoid using the phrase no slope because I think that's just a little ambiguous. When I say no slope, do I mean no slope, like there's none? 0 is the number for none, so the slope is 0, it's a horizontal line. Or do I mean there's no slope, there's no number I can use, it has to be undefined, so it's a vertical line? It's a little ambiguous, so I really just try to avoid using it, although on your homework, in the textbook, it actually uses the phrase no slope, and it means undefined. It's talking about a vertical line there. So just be aware of that. But in general, we won't say no slope. We'll say 0 or undefined, whether it's a horizontal or a vertical line. All right, so now we're going to look at 3 different ways to determine slope. The first way is from a graph. And so I have a graph of a line here. All lines have slope. You can say that it could be undefined. So we have any 2 points in the line. Okay, this one here is -2, -1. This one here is 4, 3. And I need to do 2 things. I need to first determine the vertical change from one point to the next, which I'll call the rise. And then I'll determine the horizontal change from one point to the next, which I'll call the run. And so I'll start off here by determining the rise. And so the rise starts at, I'm going to start at the point on the left. And just count up until I reach a level on par with the 4, 3. So I'm going to go up 1, 2, 3, 4. I'm going up 4. Now, up on the Cartesian plane is a positive direction, and plus 4 there is my rise. That's my vertical change there. I'm now going to, from my new point, which is here above my original point, move across to the right until I get to the point that's on the line. And to move that, I have to move once, twice, 3, 4, 5, 6 times. I'm moving in this direction 6 times, and that's to the right, which on the Cartesian plane is also a positive direction. So my run is 6, positive 6. Now I can figure out the slope by using the fraction rise over run. So when I set up rise over run, I just substitute in the 2 values that I have. My rise is a positive 4, my run is a positive 6, and that reduces to 2/3. Now, I want to keep it as a fraction here. Even if it's an improper fraction, I'd want to keep it like that. I almost never want to make slope a decimal. If it works out evenly, I can reduce it to a whole number, but otherwise I want to leave it as it is here. Now, it doesn't matter which point I start at when I'm determining slope here. I could have chosen to start at the point 4, 3. In fact, if I do that and I find the vertical change, I'm going to go down 1, 2, 3, 4. I'm going down 4. Down on the Cartesian plane is a negative direction. Now from that new point, I'm going to go to the left. 1, 2, 3, 4, 5, 6. I'm going to the left, 6, and the left is, once again, a negative direction. Well, if I use those two negative values, negative 4 over negative 6, the negatives cancel out, and then 4 over 6 reduces to 2/3. So either way, I end up with the same slope. Any line that goes up from left to right will have a positive slope, because either the rise and run will both be positive, or they'll both be negative, depending on how I've calculated it. A line that goes the opposite way and decreases from left to right will either have a positive run and a negative rise, or a negative run and a positive rise. Either way, my total slope will be negative. So a negative slope goes down from left to right, a positive slope goes up from left to right. And that's how you use a graph to determine slope. All right, let's look at method number 2. Another way to determine slope is to use 2 points and use a formula. Now, given any 2 points, 3, 2, and 5, 6, for example, we're going to call one point x1, y1, and the other point x2, y2. Now, it doesn't matter which one you call x1, y1, which one you call x2, y2, as long as the x1 and the y1 stay together. I can't call this x1, y2, for example. It has to be both 1s and both 2s. But it doesn't matter which one's which, just like in the last problem, where it didn't matter which point we started at. Then I just use this formula. M equals y2 minus y1 over x2 minus x1. So I'm just going to plug into this formula. M is the symbol for slope, which you probably remember from Algebra 1. But y2 minus y1 is going to be y2 is 6 minus y1 is 2 over x2 is 5 minus x1 is 3. And then I just simplify. 6 minus 2 is 4. 5 minus 3 is 2. And 4 over 2 reduces to 2. We want to leave our answer as 2 here. We don't want to leave it as 2 over 1. Even though we're okay with fractions for slope, it's easier when we're writing an equation to use the whole number if it's a possibility. So if it reduces all the way to a whole number, leave it as just 2, not 2 over 1. We'll use 2 over 1 when we're writing, when we're using slope, maybe when we're multiplying by a fraction, but we have to leave it as 2 for our final answer to be fully simplified. This is a good method to use if we don't have a graph, we don't want to graph, if our points contain decimals or fractions or variables, which you will be looking at. The formula will always be a way to calculate slope. All right, so that's method number 2. Let's look at method number 3. Now, this third way is actually a really convenient shortcut if you're given the equation of a line, specifically an equation in standard form. From an equation in standard form, which is ax plus by equals c, a number times x plus a number times y equals a number, we can determine the slope just by using this formula here. M equals negative a over b. Remember that a is the coefficient of x and b is the coefficient of y. So in my first example, 3x minus 6y equals 10. My 3 is my a, and my negative 6 is my b. So when I try to figure out the slope, negative a is negative 3 over b is negative 6. And negative 3 over negative 6 just reduces to 1/2. So without doing any other calculations or graphing, I found right away my slope is 1/2. Really, really convenient. Now, the next two are also in standard form, but if you remember from the previous lesson, these are special cases. X equals 5 represents a vertical line. And since it's a vertical line, we know that its slope is undefined. Now, that's pretty quick and pretty convenient. Just from looking at the equation, we know it's a vertical line, and the slope, therefore, is undefined. We can do a similar thing looking at the bottom example. Y equals negative 3. which we know is going to be y equals a number, means it's a horizontal line. And as we discussed earlier, all horizontal lines have a slope of 0. So once again, just from the equation, we can get the slope. But I do want to show you the connection between these things. I can actually write the x equals 5 really clearly in standard form. If I think about how I got the y to disappear, I can rewrite that as 1x plus 0y equals 5. You can see that that's exactly the same thing as x equals 5. And now if I use that formula of m equals negative a over b, my slope is going to be negative 1 over 0. That's the negative a over b. However, negative 1 over 0, we can't do that. We can't divide by 0. That's not allowed. That's why our equation is a line that has an undefined slope. Now, similarly, for the second problem, for y equals negative 3, or the third problem, I guess I should say, I could make that 0x plus 1y equals negative 3. And then using that slope formula of negative a over b, that's going to be negative 0 over 1. But negative 0 is just 0, and 0 over 1 is 0. So, using that same formula, I can see why, for the horizontal line, my slope is 0. Now, you don't need to go through that process every time, but that's the background. That's why it works. And that's what we're really focused on here, is understanding where this math comes from, why it works, so that we can understand and reason with it. All right, that's how we find slope. Now let's use it. We can use slope and a point in order to graph an entire line and therefore find all the solutions to some equation, even if we don't have the original equation. What we do is we use a given coordinate pair as a starting point. And then we'll use slope as rise over run to find the other points. We'll connect all the points together to make a line. So I'm going to start with the point 2, negative 1. Now that's going to be in the fourth quadrant, over 2 from the origin to the right, and down 1 to this point right down here. That's 2, negative 1. And now my slope is 2 over 3, and I can write that by having 2 over 3 be treated as rise over run. That means that from my original starting point, I can have a rise of 2 and a run to the right of 3, which would put me at this point right here, which happens to be the point 5, 1. Now that's 2 points. That's good enough. But I could also get some more points by thinking about another way to get 2/3 by making both 2 and the 3 negative. Clearly, the negatives would cancel and simplify to 2/3. But now I could go back to my starting point and have a rise of negative 2, which is down 2, and a run of negative 3, which is 3 to the left. So that will bring me to this point, which is at negative 1, negative 3. And I could actually continue that once more and go down 2 and left 3 and have this point, which is, I believe, negative 4, negative 5. And all 4 of those points, actually, you see, do line up. So I can connect them and draw an arrow on either end to show that I have continued this line in both directions. And that's how you can use slope and a point to graph a line. If I put this into an equation and got slope-intercept form, my y-intercept would actually be kind of a messy number. I think it's negative 2 1/3. That's tough to graph. We didn't need to do that here. We were able to, fortunately, use our point as a starting point and have our slope tell us where to get to the other points from there. All right, so there we go. That's how you use that information, and now you know how to find and apply slope. Hope that this is clear.